गुड इवनिंग एवरीवन। आज हम एल्डिहाइड कीटोन एंड कार्बोक्सिलिक एसिड का पार्ट 2 स्टार्ट करने वाले हैं विद द केमिकल रिएक्शन ऑफ एल्डिहाइड एंड कीटोन्स। फर्स्ट ऑफ ऑल वी हैव न्यूक्लियोफिलिक एडिशन रिएक्शन, वेरी इंपॉर्टेंट पार्ट विद रिस्पेक्ट टू योर बोर्ड एग्जामिनेशन। नाउ सी, जैसा हम पहले पढ़ चुके, ये कार्बोनाइल ग्रुप में कार्बन पार्शियल पॉजिटिव और ऑक्सीजन पार्शियल नेगेटिव होता है ड्यू टू डिफरेंस इन इलेक्ट्रोनेगेटिविटी। अब ऐसे केस में अगर कोई भी न्यूक्लियर फाइल आई नेगेटिव चार्ज स्पीशीज और अ स्पीशीज विद लोन पेयर अगर कार्बन पर अटैक करती है तो वो उसके पार्शियल पॉजिटिव चार्ज से अट्रैक्ट होकर के वहाँ पर अटैच हो जाती है, और उसी इनकमिंग स्पीशीज़ में अगर कोई इलेक्ट्रोफिलिक ग्रुप होता है तो वो ऑक्सीजन के नेगेटिव चार्ज से अट्रैक्ट होकर उस स्टेप पे जाके अटैच हो जाता है ऑक्सीजन से। रिएक्टिविटी का ऑर्डर डिपेंडिंग ऑन बल्की ग्रुप, जितना कम बल्की ग्रुप है उतनी ही ज़्यादा रिएक्टिविटी होती है न्यूक्लियोफिलिक एडिशन रिएक्शन में। नाउ फर्स्ट इज द एडिशन ऑफ हाइड्रोजन साइनाइड। हियर Cn negative and H positive ion attaches to the polar opposite carbon and oxygen atoms and form cyanohydrin OH and Cn on the same carbon. Next we have sodium hydrogen sulfide NaHSO3. Here H positive and NaSO3 negative are formed. H positive attaches to the oxygen atom and SO3Na or OSO2Na. The reason we write it this way because carbon oxygen bond is more stable as compared to carbon sulfur. Therefore, writing in this manner guarantees you no reduction of marks in your board examination. And this product, sodium hydrogen sulfide bioadduct, is a white crystalline solid. Now, this reaction is used for the separation and purification of aldehyde and ketones. This is because addition compound formed is water soluble and can be converted back to the original carbonyl compound by treating with dilute mineral acid or bases. Now we have addition of Grignard reagent. Similarly, in the Grignard reagent, MgX is a collectively positive compound, and here the alkyl group R is considered a negative charge. Therefore, it comes and attaches to this species, and after hydrolysis we get alcohols. The type of alcohol depends upon the aldehyde or ketone which may use. If we had used formaldehyde, it would have been HCHO, that is primary alcohol, HCHOH. If any other aldehyde would give a secondary alcohol, and any ketone would give you a tertiary alcohol in this case. Now this is the formation of hemiacetal, acetal and ketones. We take aldehyde in the presence of alcohol and HCl gas. ROH gets divided into H positive and RO negative, and they similarly, as discussed above, attach to the opposite charge species of carbon and oxygen. This species is known as hemiacetal with an alkoxide group and hydroxide group attached. Now if we do treatment of it again with alcohol and acidic medium, then we get both side alkoxide group attached OR, and this is known as acetal. Here hemiacetal means only one acetal group, and here acetal means both of the attached species are acetal. Now when you do this reaction with ketone, it requires diethyl alcohol, which is also known as glycerol, in the presence of acidic medium. Here the following structure is formed. We simply do the removal of water, hydrogen from both of the alcoholic group and oxygen from the carbonyl group get removed, and the rest of the structure gets combined together in the form of ethylene glycol ketone. Now next is the most important part of this reaction sphere, addition of ammonia and ammonia derivatives. Now the simple method here is the removal of water molecules that we will discuss. Now let's take formaldehyde. When you react it with ammonia, you get a compound hexamethylene tetramine, which is also known as urotropin. This has occurred due to we have taken 6 moles of formaldehyde, therefore we have gotten 6 moles of CH2O. What we have simply done is removed the oxygen from here and the H2 molecules from the ammonia to get the following product. Similarly, if we do this reaction with RNH2, the H2 from here and the oxygen from the aldehyde group gets removed, which give you RCHNR, which is known as Schiff basis. Now we can do this reaction with any group containing NH2. We simply remove this part, which is considered red water, OH2, and then the remaining of the species is added as it is. Here Z can be alkyl, aryl, hydroxide, amine, everything which will be discussed in the below table. If Z is alkyl, then we'll get a simple amine. Substituted amine is the product which is known as Schiff basis. If we have OH, then the product will be NOH, which is oxames. If we have NH2, then the product would be hydrazone. Reagent is called as hydrazine when we have N2H4. If one hydrogen is substituted by the phenyl ring, then it is called phenylhydrazine and the product is phenylhydrazone. If you have ortho and para position have nitro groups on the phenyl ring, then it is 2,4-dinitrophenylhydrazine, which is a prominent test, an indicator for your aldehyde and ketones also in the practical chemistry of salt analysis. This gives the products of 2,4-dinitrophenylhydrazone. And the last is semicarbazide, which have NHCONH2 in place of Z, which is known as semicarbazide and gives you the product as semicarbazone. Now the next chemical reaction is reduction. We have two named reactions here, Clemmensen reduction and Wolff-Kishner reduction. Both apply for ketones. Clemmensen reaction as zinc amalgam. Zinc with Hg is known as zinc amalgam in the presence of acidic medium, gives you alkane as the byproduct. Similarly for Wolff-Kishner reduction, we have N2H4 and then ethylene glycol, which gives you alkanes as a similar product. Both of these reactions have the same final product, the main difference being the reagents. One uses zinc amalgam and acidic medium, the other uses hydrazine and ethylene glycol. Hydrazine is N2H4. Now, by using different oxidizing agents, we can oxidize aldehyde into carboxylic acid, such as by HNO3, KMNO4, K2Cr2O7, etc., or even by mild oxidizing agents. RCHO can be converted into RCOH. Ketones are generally oxidized under more vigorous condition, that is by strong oxidizing agents at higher temperatures, such as KMNO4, K2Cr2O7, etc. Now we have the different types of tests, which you have Neol physical salt analysis and functional group, as well as theoretical syllabus. The first is a tolerance test. Tolerance reagent is ammonical silver nitrate, which you can see here. It gives a bright silver mirror when it combines with aldehyde. The silver gets deposited in the test tube and you get a silver mirror like appearance from this test, which can be used to identify aldehydes. Felling's test. Felling solution give a reddish brown precipitate with aldehydes except benzaldehyde. This is some detail which you have to remember for your examination point of view. Whenever you have a 5-marker question about identifying A, B, C, D, etc. Therefore, if you want to identify benzaldehyde, then one of the hints is here. It can give tolerance reagents test, but it will never give Felling test. Felling solution is just a mixture of Felling solution A and Felling solution B. Felling solution A is aqueous copper sulfate and for Felling solution B is alkaline sodium potassium tartrate, which is also known as Rochelle salt. Next you have Benedict solution. It is given by aldehyde, again exception being benzaldehyde. It gives red precipitate of copper oxide. And then lastly Schiff reagent test. It is an aqueous solution of magenta color and aldehyde gives pink color with this reagent, but ketones do not. Therefore it can be a differentiation test for aldehyde and ketones also. Next, halofoam reaction. This is another major one which appears in examination multiple times and you should have your focus here. Halofoam reactions are given by aldehyde or ketones having at least one methyl group. That is, you need at least 3 alpha hydrogens here, such as in this species, linked to the carbonyl carbon atom. This is the carbonyl carbon atom with the C double bond O present. Now we take sodium hypohalite NaOX, where X can be chlorine, bromine, iodine. Generally we take iodine, therefore it is commonly referred to as iodoform test in many books also. It forms a sodium salt and CHX3 has been precipitated out here. This oxidation does not affect the carbon-carbon double bond if it is present in the molecule. Therefore, unsaturated aldehydes and ketones can also give this test. Iodoform reaction with sodium hypoiodate is also used for the detection of CH3CO group or CH3CHOH, that is secondary alcohols, also by producing yellow solid CHI3, which is iodoform. Now some reactions occur due to the alpha hydrogen present, one being aldol condensation. Another major important reaction, extremely important from your board examination point of view, occurs many times in the form of self aldol and previously in the form of cross aldol also. Now we have CH3CHO present in the form of ethanol. We have dilute NaOH. This leads to the formation of 3-hydroxybutanol when two molecules of this species react with each other. Now after we do dehydration of water, this gives you enals, a double bond forming the ene part, and L for the aldehyde part. This is your aldol condensation. It can also be given by dilute basis in the form in the case of ketones, which gives you ketols, and upon dehydration you get enones and one group in the present. If further condensation is carried out, it gives out 4-one also. This reaction is exhibited by those aldehyde and ketones which have at least one alpha hydrogen. So aldol condensation, for your examination you have to remember two things. First, it cannot be given by formaldehyde, and secondly, it can also not be given by benzaldehyde. Those two never give aldol condensation due to lack of alpha hydrogen's presence. Now cross aldol reaction carries out similarly on the same principle. You get multiple different products. You get one self aldol product when ethanol gets combined with itself, or you get a cross aldol product when ethanol combines with methanol. Now since we have already discussed that HCHO, formaldehyde and benzaldehyde do not give aldol condensation, then we will now be discussing the reaction which they do give, which is known as Cannizzaro reaction, because this does not require any alpha hydrogen. This is done in the presence of concentrated bases, unlike the above reaction which we have seen, which takes place in dilute bases. We have HCHO, which gives you two products. First is an alcohol, and the second is a potassium salt of the similar group which we had attached. Similar for benzaldehyde, you would get benzyl alcohol as well as sodium benzoate. Now for the electrophilic substitution reaction, we have aromatic aldehydes. They show a plus R effect, therefore they are deactivating and meta-directing groups, and every major product form would be meta-directing, such as nitration in the presence for the formation of meta-nitrobenzaldehyde. Thank you for your time. We will continue with the carboxylic acid part and finish this chapter in the next video. Thank you very much. Wish you well for your examinations.